Hello everybody, we'll be discussing today for the second part of the mechanical engineering video, speed changes, specifically in gears in transmission systems, gears, gear and pulley, a wheel and pulley, friction wheels, you name it. So let's start with the two size gears. You have a larger gear and a smaller gear. When we mention a larger gear, we can mention the diameter of a gear or the number of teeth. So we also have the term driver component or driven component. So the driver component is the initial gear that will initiate the movement, and the driven gear is the one that will move as a consequence of the driver gear moving. An intermediate component, the word says it, is right in the center, in between the driver and the driven. So we'll look more closely on how to calculate the ratio between the driver and the driven gears. So if you look at when you have two identical gears, we say there is no change. And even when there is a intermediate gear, the overall speed of driver and driven is equal. The intermediate gear is not taken into account. Just remember, in general, the smaller gear always rotates faster than the bigger gear. So if we look at the following gear system and we give it the same amount of teeth for both gears, we can see that they are going at equal speeds. Even if we change the gears to be equal size but larger amount of teeth, same concept, they will move opposite direction but same speed. Even with a larger gear, again, opposite direction, same size, same speed. In the case of a speed increase, we always want to see if the driven will be fast. So we'll compare the driven and the driver's diameters. So the diameter of the driven must be smaller than the diameter of the driver. So every time the driver makes one turn, the driven would have made 2 or 3 turns, depending on the size. And that's where the ratio comes along. To find out exactly how much faster the driven will go, you divide the number of teeth of the driver divided by the number of teeth of the driven. So let's take an example. Back to this. So the driven remains small, but will make the driver larger. Notice the driven's a lot faster. And we increase the size of the driver even more. You see that? The speed is increased by a lot. And to calculate, we will take the amount of teeth of the driver, 60, divided by the driven, 10, which gives you a ratio of 6. This means that the driven gear goes 6 times faster than the driver. If we bring it down to 30, 30 divided by 10 is 3. So the driven gear goes 3 times faster than the driver. And back to 10 and 10. 10 divided by 10 equal 1. So there is no change. In the case of a decrease of speed, it's the opposite rule. The diameter of the driven has to be bigger, and the diameter of the driver has to be smaller. And no matter, even if you have an intermediate in the middle, will not make a difference. So let's give it a try. Okay, so now we give it a try. We have a very small driver, 10 teeth, and a very large driven. Look how slow the driven is going, 60 teeth. So we do the same rule, driver, 10 divided by driven, 60. 10 divided by 60 is 0.16. See, the ratio now is below 1, and that makes the driven very slow. Okay, let's try with 30. Still pretty slow. Still slightly faster than the one before, but still pretty slow. So again, 10 divided by 30 will give you 0.3. to our below 1, which makes it a slower speed, a decrease of speed. And back to equal size. Equal size meaning equal speed. So just to recap, if you want to calculate the speed ratio, which means you want to calculate how much faster one gear moves compared to the other, simply use one of the following formulas. Big gear teeth over small gear teeth, or big gear diameter or over small gear diameter. But I prefer the following formula. The driver divided by the driven. Then you'll know how fast or how slow the driven will be going. So if you follow that formula down here, gear B is the driven and gear A is the driver. So if we follow the formula I just gave you, driver over driven, so you do 12 divided by 24 equal 0.5, which means the driven is slow because it is below 1. But if you use this formula, 24 divided by 12, you'll get the how fast the driver will be going, which is 2 times faster than the driven. If we look a bit lower, we have the driver 12. So again, the driver divided by driven, 12 divided by 24 equals 0.5. So the driven is slow. It's half the speed of the driver. Say perhaps I would switch over the 2 gears. I would say that the driven becomes the driver and the driver becomes the driven. Just flip it over. Now we would get 24 divided by 12 equal 2. That means that the driven would be 2 times faster than the driver. That's it for this lesson. Watch the other videos for transmission and transformation systems.